So I'd like to welcome everybody to another SLG Azure Fridays event. Before we jump into our topic today, I just wanted to hit on a couple of upcoming events. First of all, on November 24th, we're going to be actually skipping that day due to the holidays, so enjoy time with your family. December 1st, we're going to be back with Azure Logic Apps. We're going to be talking about how to integrate different systems together using Azure Logic Apps, so that should be a pretty exciting event. On December 8th, getting started on Azure for $100 a month. We're inviting back our partners and friends over at Netrix to present. And then on December 15th, the presenter today, David, will be back to give another Data and BI presentation, 500 city health outcomes using RStudio, R in Power BI, and R in SQL Database. And then when we move on to December 22nd, once again, because we're so close to the holidays, we're not going to have a presenter for the Azure community. However, we're going to hold office hours. So if you have questions, you want to ask some questions about Azure, app development, data and BI, or infrastructure, feel free to hop in during the hour there, and we'd be more than happy to answer some of your questions. Once again, all of our events start at 1:30 Eastern Time. Please register at slgevents.azurewebsites.net, the same place where you registered for this event. And all of our on-demand recordings are made available usually the following week after they're recorded, and they'll be available at aka.ms/SLG Azure Fridays. And with that, I'll go ahead and turn it over to our presenter today, David.
All right, that's an emerald ash boring beetle, and what these beetles do is they eat ash trees. Can you see the beetle with complete set of cutlery?
Yep, looks good.
But the time you said yep, there was about a 10-second delay.
Yeah, I was delayed.
Okay. Oh, okay. So everybody, these boring beetles, they're no laughing matter. Of course, the pine boring beetle killed 3.4 million lodgepole pine in Colorado. So really, they're a tremendous environmental hazard. And from a Parks and Rec perspective and a citizen's perspective, not so much as it is the impact on the environment like the Colorado pine boring beetle, but more so people in their towns and cities and counties, they like their trees. They like them in the public parks, the paths, and the easements. And there are ash boring beetles. There are oak boring beetles. Pine. There's just almost the same number of boring beetle species as there are tree. Well, not quite, but there's a tremendous number of boring beetles that take out our trees. So how would a Parks and Rec agency traditionally approach these boring beetles? Well, they commandeer the experts, and the experts would identify the beetles. The experts would record them, count them, the location. They'd analyze where they found the beetles, and then they'd prioritize some eradication plan. This approach is of course, it's costly, and it assumes there's even availability of these experts. It assumes there's even budget to hire these experts. Finding the experts, there's very little collaboration. The recording and the analytics and the photos and the analysis, that's just a non-collaborative, very expensive effort. And by the time there's finally enough data, then an eradication plan is put in place. And that time to action may be too late. So introducing the boring beetle eradication solution. And this solution is built on the idea that we can enlist the power of our citizens and our volunteers in kind of a socially interesting and civic-minded way by offering them an iPhone app. And this solution would leverage something called cognitive services to identify the species of beetle. And we'll use some different plumbing services in Azure to make this solution go to make this solution viable. Without further ado, I'm going to quickly do a demo of the solution. And here is, let me go to the actual, there we go. So here is a Power BI report that hypothetically a Parks and Rec could render this for their citizens on their Parks and Rec website. And citizens could actually see which videos have been recorded where. I'm going to simulate for you the iPhone app as if it were created, but all the other plumbing works. So here's the idea. The citizen, or volunteer, as they come across a pine boring or an oak boring or any beetle for that matter, they'll focus in and take a picture of that beetle. I'm going to simulate the iPhone app by using this Azure Storage Explorer app, and I'm going to upload a picture of a beetle. So let's do that. And in my desktop, there's some test beetles. And let's grab a beetle. Let's take this beetle 6 right here, and we'll open it, and we will upload it. And we've uploaded it to our Azure storage. There we go. We see the green light. And now you're back on the website for the particular Parks and Rec. In this case, we're using City of Sacramento. And we'll go to this other page in our report called Beetle Detail. And you can see the last submitted beetle. What I'll do now is I am going to refresh the data set where these beetles that are being uploaded to Azure Blob Store, where this data set represents all of those beetles. So now there it is, boring beetle analysis, the data set, and I'm going to force a refresh, and then I'm going to refresh the report, and lo and behold, you can all now see that beetle that was uploaded, and a link to the URL to that beetle is provided to us. There's that beetle that was uploaded. And if I highlight that beetle, we can see that Cognitive Services classified that beetle 100% likelihood it's a boar, 100% likelihood it's a beetle, and then, about a 79% chance that we think it's an oak borer, but all the other different kinds of beetles, we're going to give it 0%. So you're seeing Cognitive Services right here contributing to the eradication of these beetles. Why? Because we can then show the location of where these beetles were identified. And then those that are responsible, city managers, Parks and Rec, that are responsible for executing an eradication plan can prioritize where they go to eradicate the beetles and the appropriate treatment plan for the area where those beetles are found. So there are some moving parts to this solution, and now we're going to go back to the deck, and we're actually going to peel back the covers and look at what's going on here. So we're going to look under the hood and see what makes this go. So first, I'm going to introduce to you Cognitive Services, so you have a sense of what that is all about. And our solution uses a cognitive service called the Custom Vision Service, but we're going to initially look at another cognitive service called face recognition, because there's so much about face recognition, particularly with the new iPhone, and I'm sure those use cases people tend to understand more. So we're going to take a look at the face API. So we can provide a picture of a face, and the face API will return a JSON document that indicates all the tags related to a face, including emotion likelihood, as well as face shape and face characteristics. all of the cognitive services, they're easy to access via a REST API, and a developer can easily and quickly put these solutions together. The end game of the solution is a user being able to easily and quickly produce some really fascinating insights using Power BI, like in my case. And I just want to point out that the theme throughout this presentation is easy and efficient, from the citizen taking the picture to develop and building the plumbing, all the way to the Power BI reports. And now you can certainly see in the middle of your screen for that particular picture, right in the middle of that JSON document, a 10% chance that face is angry. There's a 83% chance that picture represents somebody that's happy, and you get the idea. Let me just get some acceleration going here. So back to our boring beetle eradication solution. As I stated, the idea is that we start with empowering the citizen, and what great way to do that than providing some very easy to use app on their iPhone or their, pick their smartphone device. And what we can see now are the components that make this solution work. And I'm going to speak briefly to these accelerators, these different services that we offer. And I just want to reiterate this notion of fast. And if you were interested in a solution like this, say 10 years ago, I think we all know that would have taken hundreds of thousands of dollars, and if not millions, and months if not years to develop. But welcome to the cloud and the ease at which major corporations and vendors can then surface their IP and then algorithms for others to consume, and their services, of course. And cognitive services is all about that. But we're going to go through the different plumbing components, and I just want you to follow the red lines for this solution walkthrough. We're going to zip on through the iPhone app. It doesn't really exist. I use the Azure Storage Explorer, but I do want to give notable mention to the Xamarin platform, which makes it very easy for developers to write these cross-platform iOS apps. And you can certainly bing Xamarin, and there is a ton of information out there, some tutorials, some get started, and I encourage everyone to kick the tires with the Xamarin platform. And now getting to the plumbing, and as you saw, I did upload an image to the Azure Blob Store, and it's very straightforward to configure an Azure Blob Store. In the Azure portal, search for Azure Blob, and now we go through the easy steps to set up a storage account. We indicate what kind of storage. Is the storage hot or cold storage? Do we want standard or premium SSD storage? Is there redundancy? Things of this nature. And now we need, for this storage account, we're going to set up, we're going to indicate that for this storage account, we need to store blobs. And for this blob service, we're going to create a container. Think of a container as a folder, and that's where we're going to drop our Beetle images. So you give that container a name. Our container is called Beetle Capture. We make it public anonymous so that people that are using that iPhone can post their Beetle images up there. And we're going to keep track of what's getting posted to that Beetle Capture container using an Azure function trigger. So we're done now with the storage account and setting up the container. So we're going to make that component to our data flow yellow. And now I'll take your eyes to setting up the Azure function. So now that we have that blob container, let's associate it with an Azure function. And this is an event-driven serverless architecture. It's extremely easy for developers to execute code for any number of supported events, such as HTTP requests, timer events. In our case, it's a Blob Store write event. So let's take a peek, go back to our, let's set that Azure function up. We're going to go back to our Azure portal. We search on function, we see function app. And now a very similar dialog to setting up a storage account. We need to give that app a name, and that app will have one-to-many functions associated with it. Of course, we assign a resource group, some kind of a hosting plan. And it's pretty cool because we can assign how many cores we're going to need for that app, for all those Azure functions to execute in, what our memory requirements are, SSD. So as your solution gains popularity, you can just come in and you can increase the compute resources associated with the Azure app. So that's super cool stuff. So now we're going to go to the dialog where we set up the Azure function, and that's actually the code that will be executed when that Beetle image is posted up to the container, like I showed you in the brief demo. So we're going to click on Custom Function, and we will indicate we want a blob trigger that will fire some C# code. So we choose that, and this is where we indicate for this function we want it to be looking at that Beetle capture container. And we click on Create. We're given some stubbed out code. And if you took this code right here and you dropped any image into that container, this string is what will be logged in Azure. Of course, that's not the capability that would make our solution go, but that's how easy it is to get bootstrapped with an Azure function. I used Visual Studio, and I pulled down some necessary libraries so I could code to the Azure function. And this is where I put my code. And in the Azure function, we're given we're given the name of the image. That's the first argument to the run method. That's the name of the image. And we're given a handle, a stream handle to the actual image itself. And then we can just set up some very simple C# code to allow us to read that image when it's triggered through the Azure function. We can then take our Azure function that we've written in our Visual Studio. We take that code and we publish it up to Azure, to that Azure function app that we created. And once up there, then we can start using Visual Studio to debug our code. So that's awesome. Our Azure function is all set up. And now let's have the Azure function, let's have it make that custom vision REST call to a prediction API request, and it will give us back the JSON response for those beetles that are getting dropped into that Azure folder. So before we can call the HTTP prediction call, before we can make that call, we go to customvision.ai and we need to train our model. We need to tell it about these beetles that you're going to see. We're going to need to train it what a pine boring beetle looks like, what a ash boring beetle looks like. So we go to customvision.ai and we set up a new project. And we indicate what the domain of the images are. In our case, it's general. And now we upload some images. So we go grab a bunch of, in our case, we're going to grab a bunch of ash boring beetle images. And now we must tag those images so that the algorithm knows for these images that will then get posted. It will go, oh, well, based on what I know about an ash boring beetle, that must be an ash boring beetle, or that isn't an ash boring beetle. So we're going to tag it with one tag, beetle, it is a beetle, and then we're going to type in another tag, it's a boring beetle, and then we're going to even get more specific and type in, it's an emerald ash beetle. So with those tagged, what do we have to do? Now we train the algorithm, and it chugs along. And for sake of time, I'm not going to get too much into this, but basically precision of 93%, it means when the algorithm says, hey, that's an ash boring beetle, for example, it does an excellent job. When it says it's an ash boring beetle, there's a 93% chance it is. But of all of the ash boring beetles, it will get the recall, it will get 91% correct. So then we can do a quick test. And with that test, let's go grab a different beetle that we didn't train the model with. So we're going to grab that beetle. Everybody can see that beetle. Does that beetle look anything like the beetles that we trained our model with? Not so much. It doesn't have the long spindly legs. It has that brown glossy body. So let's see what the algorithm comes back with. Yep, for that limited trained model that we have, it says, hey, based on what I know, that's not a boring beetle, it's not a beetle, it's not a pine beetle. So that's pretty impressive, but we probably need to make our model a bit more sophisticated. And I certainly did that. I identified 3 species of beetle. But now let's grab an image of the ash borer, and I'm doing that. And sure enough, it really nails it. It's a beetle, it's a boring beetle, and it's an emerald ash beetle. So our model is set up, and from the customvision.ai portal, we also give you some conveniences like the REST call you need to make for the various REST functions. And this one, it's a prediction function. And we're going to give it I need to update this. We're actually giving it a URL to the image. We aren't sending through the, we're actually going to build out from the image name a URL. That's the prediction call above. And by the way, if you go out to documents and you look at any of the cognitive services, we provide an API test console where you can plug in your prediction ID and your project ID from whatever your particular cognitive service project is, and you can test your model just by calling using the API console. So the code behind that goes into the Azure function, it's not super complex. We allocate an HTTP client. We set up our default request header. And we provide it that prediction key. And we build out the REST URL string for the prediction call. And notice at the end of that URL is the actual name of the image. And then and then what we do is we create that HTTP response, and we now get our image data. And then from our image data, we will then actually, I am using the stream. I apologize. My code has taken a couple versions. So I'm actually taking the bits, the byte stream that was given to the function versus using the URL to the image. I was experimenting with both. In this case, we're getting the actual byte stream. We're building out the body of the REST call, and then we're making the call to the cognitive service. And then the cognitive service, it gives us back the JSON for that particular image, and you can see that JSON right here. What we can then do with that JSON is we can deconstruct it, we can put it into an Azure SQL database, and that's what we did for our solution. Speaking of which, now let's move on to the SQL database component of the solution. So go back to the Azure portal, search on SQL database, and now we set up the SQL database by providing it the database name, and we can also indicate whether we want this particular SQL database to be part of an elastic pool, and that means that it's an interesting concept because now the elastic pooling can allow many SQL databases to share a common pool of compute resources, which is pretty slick. So now I can have a number of different SQL databases, and they all work together with a pool of compute and RAM resources. And establish our pricing tier, which is associated with the scale of our database. We can indicate whether we want this database to be geo-replicated with a click. So it takes all of 5 minutes then to indicate, well, it depends on the size of the database, but it's pretty darn quick. With a click, we can indicate somewhere else in a different Azure region altogether, we want that SQL database to be replicated. And you can actually use that other location to read from as well. So you could potentially offload heavy transactional traffic to one location and then read from the other. And you can set up threat detection. It's really cool. We can also set up some dynamic data masking, and that allows us to create a mask and rules where we limit what users see when they're querying different parts of the database schema. I just want to kind of show you how easy what we call platform as a service makes it for the data architect to just light up these capabilities, which if you did this in an on-premises database management system, it's going to take a bunch of code, and you're going to be responsible for managing that. We take care of it for you. So you can turn on data encryption. As we indicated, you can also then indicate how much scale you want that particular SQL database to represent. So that's going to be, is it IO intensive? How much RAM does it need? Just using a slider. And then we grab the connection string for that SQL database, and that connection string is where we're going to put that JSON document. It's also where we will deconstruct that JSON and its tags and put them in traditional relational columns that then Power BI will read. And just so you can see, we now go to SQL Server Management Studio. We point it to our Azure SQL Server name, and we log in, and hey, it looks just like SQL Server on premises. And I've created all of my boring beetle schema here that receives the JSON, and that we then deconstruct into relational columns. And really quickly, this is just a quick detour. This is sort of separate from the boring beetle, but I want you all to just kind of get multiple different sub-educational aspects from this presentation, even separate from the boring beetle. Just really quickly, this is how easy it is to migrate an on-premises database to Azure SQL database. So as I already showed you in SQL Server Management Studio, you can go, we're looking at an on-premises database here, and what I can do is I can right-click that database. Any of you that spend any time in Management Studio, you'll find tasks, and then for tasks, you can see that there is a deploy database to Microsoft Azure SQL database. And we walk through the dialog, and that thing is successfully migrated to Azure SQL DB. make a footnote to yourself that there could be compatibility issues, and that's where we provide tools like Database Migration Assistant. It's a free download, and you can point it at your database, and it will report to you anything that you need to fix before you do that really quick and dirty technique that I just showed you. But it's for many SQL on-premises workloads, it's truly that easy. Back to our code. So what have we done? We have called the REST API for that prediction call. We've got our JSON back that describes that image, right? And now we're going to take that JSON and we're going to write it to that Azure SQL database that we just provisioned. So we grab that connection string that we copied from the Azure portal, and we open a new connection. Anybody that's played in ADO.NET, this should all be pretty familiar. We open a new connection to the SQL database instance. We build our command string, and we're going to call a stored procedure. And in that stored procedure, we're going to send different parameters. We're going to send the JSON document. We're going to send the date, time. We'll send a URL to the actual image itself, and that's the URL that I clicked on when I showed you the Power BI report. So it's very compact. So we just execute that command, and once complete, it has written to that Azure SQL database. And what we're also going to do is, that JSON document, there is a NoSQL solution that is very scalable, incredibly fast, that we can provide, that we can write that JSON to. And that could be a great place that we can archive all those JSON documents. You may have other JSON solutions in-house that you want to write to different collections in this. It's called Cosmos DB. And it's really just an outstanding platform. It's fully managed. It's a NoSQL platform. It's globally distributed. It's horizontally scalable. It has tremendous I/O throughput, and it's a multi-modal modal database service, and it has great SLAs. And if you played with Document DB, this is the next generation of DocDB, and we guarantee less than 10 milliseconds latency anywhere in the world. We automatically index all the data, and it natively supports a few NoSQL APIs. One of them is JSON, which is based on DocDB, and that's what I provision mine for. And it's really easy. It's really nice because that supports a SQL query access. If you're a shop that uses Mongo, then we fully support Mongo, which is also JSON documents. It's just if you're used to using the Mongo API approach to your development, then we support your skill set. Azure Table Storage, that's more of a key value pair structure. Gremlin is a graph-based system. So Cosmos is this very flexible platform, and we're just using it to archive our data. It's not part of our visualization and analytics, but it could be. I just wanted to introduce Cosmos to everybody so you have it in the back of your head. If you're a Mongo shop, you should be thinking about looking at Cosmos. By the way, another cool thing about Cosmos, if your JSON tags have lat longs in them, Cosmos provides out-of-the-box spatial queries. So you can make queries about, is this JSON record, how many kilometers is it from this other record, assuming that you have tags that are location-based tags. So we go through another provisioning service, and I'll just crank through these. We set up some throughput capacity using these things called RUs. We indicate you have a notion of a collection, and a collection has one-to-many databases, and ours is called the DB Cogs JSON docs. That's what I called. and I write my my JSON from my cognitive services out to that collection. So you could have a collection for your boring beetles, you could have a collection for your face, a collection for your image, your text recognition, and then you can query over those. So very powerful stuff. And I'm just going to kind of quickly go through. So I have a little code fragment in that Azure function that very simply, it opens a new document client, and it creates a memory stream for that JSON document. And then finally, I create the document in our collection, and we are now good. That's not a lot of Azure function code. I think I counted it, and it's really about 30 lines of code where it calls the cognitive service, gets the JSON back. It writes the JSON to Azure SQL DB, and it writes the JSON to Cosmos. So now to the fun and the cool visuals. If you haven't seen it, or if you haven't worked with it, download the Power BI desktop. That is a free authoring platform, and you can, in that platform, indicate get data, and we point it at that Azure SQL database that we loaded our JSON to. And quickly, just to show you just to focus in on this, this is the schema that where those red arrows go, those are two views. Those two views make everything just look like rows and columns, because in those two views, I've used the new JSON constructs right in my T-SQL code. So that's where I have deconstructed the JSON document into the tag name, the probability for the tag, and I've just put it into a separate view. So I have a one-to-many relationship where for the beetle image, I've got the URL to the image, and then I have one-to-many tags associated with that image, and for each tag, the probability that it is that particular tag. So from the individual using Power BI desktop, they don't know what JSON is. They just click on the beetle collection and the beetle tags, and it's loaded, and voila, they have a one-to-many relationship. Oh, I know what this stuff is. This stuff makes sense to me. So now I have a beetle. I have the longitude and latitude for the beetle, the image, date, time, and then the many tags associated with the beetle. This thing is fully dynamic. I hope everybody understands that if I go back to my customvision.ai model for beetles and I add additional tags, this will just simply pick up those new tags, and nothing breaks throughout the system. It's fully dynamic. So there's a blowout of the beetle collection view in our Power BI desktop. And now you'll see the beetle ID on the left-hand side there, and then the one-to-many tags, and then the probability for each of those tags. And now we can start to drag matrices and maps and tables and images onto our design service of Power BI desktop and create some really compelling reports that let us both inform the public, but also make it actionable for Parks and Rec in the background. We publish that Power BI desktop up to the Power BI service that's running in the cloud. And now we can, I already showed you this experience actually working, but now the city of Sacramento or the Denver Parks and Rec, what have you, they can put a rendering of that report right inside of their portal that the public sees. How cool is that? The public could see that embedded Power BI report, and they could even look at the, I'm showing the first page in that report, but you could look at that second one, and they could, this one right here in the lower right-hand corner, they could go, hey, Mom, look, I took a picture of the beetle, and you can see the last submitted one. check it out. That beetle, there was a 98% chance that I took a picture of a pine borer, and Mom says, "That's awesome. Way to go. You just contributed to keeping the trees healthy and alive in our park system." So if you extend this architecture, like with all of our services, you can start simple. You can start small, and then you can surround and extend these services to richer solutions, more highly scalable solutions. This solution could include entomology, forestry, seeding, staffing, easement. You could use some of the other cognitive services, and it could be public safety, where you're taking pictures of every minute of key intersections, and it notices that faces appear, and then it notices those faces are maybe getting angry, and now a cognitive services starts to read signs, and the signs have aggressive language. So you could use it to be proactive in public safety. You could use analysis services, platform as a service, and have incredibly fast analytics performed. You could use machine learning services that point to that data set and are actually looking for patterns. So gather the images, target them, and eradicate them. These are the two bookends. You have the citizens using the app, and then you have the eradication experts in the background, in the back office, looking to see what's been posted, and then they take action on it. So it's really a great citizen participation and effective way to really eradicate these boring beetles. And the rest of the document is just a couple slides that show some levels of best practices. So that is we have 10 minutes left, and with that 10 minutes, I want to show you all one other part of the demo. This is just kind of fun, and it kind of sees if you're listening. Brendan, Chris, and Melinda. There's 3 of you left. So check this out, guys. I'm going to take you to an image in my test beetles. And I want to show this image to you. There we go. So a couple buddies of mine, we go to Moab every year and mountain bike. And these 2 buddies, Richard and Doug, they're standing on top of a rock in Moab. So I'm going to go to my Azure Storage Explorer. And I am going to, don't worry guys, I'm not going to put anybody on the spot. And I'm going to go ahead and grab the image of Doug and Richard in Moab. And I'm going to upload that. And while that's uploading, which shouldn't take long, what do you think, and again, I'm not going to ask you, I'm not going to put you on the spot, but what do you think that particular image is recognized as? Any guesses? Just think it to yourself. You know, again, I'm not going to be putting anybody on the spot. So I'm going to go back to the data set that's running in Azure SQL Database. By now, the JSON should have been written to my Azure SQL Database. So I'm going to refresh. I hope it, because it's been pretty snappy today. Sometimes there's a real lag time. I'm going to go back to my Power BI report, and I'm going to refresh it. Wow, it's really snappy today. But look, last submitted, Doug and Richard, the image of those guys standing on the rock. I'm going to come up here and I'm going to click on that image, and I'll take your eyes to the table in the lower left-hand corner. What do you think cognitive services that I've trained to understand what a pine borer looks like, what an emerald borer looks like, and what an oak borer looks like, and of course the Lennon beetle. But I've trained it what those look like, and watch when I click on that. It says 67% chance it's a pine borer, but it's an 11% chance it's a borer, and even less that it's a beetle at all. So what does that mean? That means we might need to get a little more sophisticated with our model, because what it picked up on if I showed you the pine boring beetle, the pine boring beetle happens to have a body that's brown and has a lot of variance of brown and kind of these striations. So the cognitive services picked up on this as the dominant frame in the image and said, that's the pattern that I need to score. So if you see something like that, it kind of tells you, well, maybe we need to drop more pine boring beetle images into the Azure Blob Store. There's another option. In your Azure function code, you can make the decision. If you get an image that comes back at 0% chance it's a beetle or a borer, but the specific kind of beetle comes back at a higher percentage, you can make the choice that you're not going to write that to your Azure SQL database that's rendered in the Power BI reports. You could put it off to a inspect these images table that nobody sees except people in the background going, let's check out and see what people are loading. There's also another REST API cognitive services call you can make in the Azure function. It's called a moderator. And the moderator will give you a scoring for the image posted on whether it's racy or not. So if it's inappropriate content and the JSON that comes back from that service, then in your code you could simply say punt. I'm not even going to save this. So that's a little tangent from the solution. It's kind of fun to see that it, garbage trained, garbage probability. This isn't quite garbage, but the notion holds. And that brings us to 6 minutes left, and I hope everybody enjoyed this exclusive invite to our solution.
So David, real quick on that, kind of going back to the model, like you said,
yeah.
Important. So about how many beetles did you train on your model?
Very good. So the minimum number of images for each tag is 5.
Okay.
That's the minimum. But the smarter the model, it means that you're collecting images. Really, well, it kind of depends on the image, Mike, but I could foresee you collecting many images. Depending on the complexity of the image, it could be 30, 40, 100, a couple hundred, whatever you need to make it smarter and smarter. But there is sort of this diminishing return after a while where, I don't think we're getting more improvement in our model. So 5 is the minimum, Mike, for each tag. Okay. And in my case, I had about 30 images for each of the 3 species of beetle.
Okay. That's very good. And then, like you said, it's kind of interesting how the cognitive services goes about identifying, what's in an image, because it's so different than the way that I think that I do it. And so when I look at something, I can immediately pick up that this is a beetle or an animal or some living thing that's on a rock or on grass or something like that. I can immediately identify that. But for a computer to do that is actually pretty remarkable. And
it sure is. It sure is.
And in order for it to understand, like you said, it's looking for patterns. That's how it's doing it. And so it doesn't necessarily know where in the picture to focus. It has to look at the picture as a whole.
And that's illustrated in this picture of Doug and Richard. I'll have to let those guys know they're forever caught on a video. But you're exactly right. What did the model do? It said, I'm going to focus in on this. But if you trained it with, I'm just wondering, I didn't have the time, but if you trained the model on many more pine boring beetles, you got to wonder if it would start to pick up that the spindly legs are a really important part of the algorithm. And if it sees an absence of them, it's not confident to give it a higher score, if you know what I mean.
Yep.
But you're exactly right. Our human brains go, I know it's a beetle. It's got spindly legs. But we even look at motion too. But it's remarkable. And what's incredibly powerful is we provide 30 of these cognitive services across so many different subject domains. And it's really Microsoft opening up its IP, its Microsoft research, its Bing work. I mean, think about Bing and the algorithms that work in the background for search. We've decided, let's take all that IP and let's expose it through these REST APIs and let developers access them. It's really, really impressive stuff.
Very phenomenal. Well, thank you very much, David, for presenting today. I really appreciate that. And, I wish we would have had a few more people on today. We had quite a few that were registered, so I don't know if we had some Skype issue or something that we noticed at the beginning that kept some people from connecting. But anyway, we will be having additional events coming up. Like I said, next Friday, we're going to be skipping that one for the holiday, but we'll pick it back up in December. So once again, thanks a lot, David, and we'll go ahead and wrap things up.
And we've got the recording, right?
Absolutely. Absolutely.
All right.
Thank you.
You bet. Bye.